Okay, this course will be on basic electricity. All bodies of matter contain what's called positive and negative charge. If we have equal amounts of equal clump of positive charge and equal amount of negative charges, what the body is called in a neutral state. Now, if we were to somehow to add, so this neutral state basically cancel each other out. So the net overall charge of that body is it's in equilibrium, and it's basically a net charge of 0. Now, if we were to somehow add a big clump of positive charge to this body, we would attain a charged body. So let's say again, we're going to add a big clump of positive charge. So the overall charge on that would be positive. Or if we were to take this neutral body and add a clump of negative charge, the overall charge of that body would be negative. Now we have two charged bodies. And the rule is, or the law is that positive and negative charges have an attraction, and negative like charges have a repulsion, and unlike charges have an attraction. So these two would attract each other. And by Coulomb's law, it would basically be an attraction with a force that's equal to some constant times the charge on one represented by a little q, and the charge on the other represented by another little q, divided by the distance or radius squared. So the distance from that tells how the force of attraction in this case. If it was two positive charges or two negative charges, it would be a force of repulsion. But let's just stick with the two negative charges of attraction. These this overall rule is similar to something that doesn't necessarily deal with electrical charges, but with pressure, gravity. But it has a similar kind of insight to it. So if we were to take this new tube of water or tube and fill it with water, it'd reach its natural level on both sides, equal level. And all of a sudden we would provide a barrier, a separation. And then on one side of that separation, we add extra, let's say in this case water, but we could say add extra charge, say up to this level. And I know by intuition or experience that it's going to equal out. So you would basically have a net positive charge and a net negative charge, or net negative level of water and net positive level of water. And they would, if we were to take down that barrier, it would come down to equalize and become in a neutral state, if you will. Just as if I were to take these two charged bodies, this one and this one, and now that they're charged, and bring them together. Now let me just back up a tad. Now you can also imagine to say this one had a plus. I'll just draw a dash. Well, I can't do dashes very good, but and then on this one, I can remember that there's still other charges here, other clumps. And that this actually still has, these cancel each other out, the plus and minus, and you have a net positive charge. And then over here, these cancel each other out, and you have a net negative charge. But there's still clumps of charges there. So once these touch each other, all of a sudden, this guy fulfills that guy, and that guy fulfills the need of this guy, and it cancels, and it basically reaches an equilibrium. And again, unlike charges attract. Actually, I can draw it like this. I'll just say they both have forces that want to go this way towards each other. And then, unlike charges, say they were both made negative, they would repel each other. So that's the basic of charged bodies. Let me make some space for some more info. Now, how can we provide charges on bodies? Well, and provide that potential force difference between the two charged bodies. How do we provide that? Well, we can do it, say, there's friction. Let me go up here and get the ink. There's the basic ways, and there's many ways, but the basic ways are by friction, chemical, and sunlight. Sun. And there's electromechanical, and there's pressure, and there's heat. But I'm going to kind of focus on these ones for the next few modules. So friction is the most common sense one that we're most familiar with. Like you brush your hair with a comb, and you take the comb and it'll pick up paper. There's that law of attraction. Well, this was observed back, in the Greek days. So I'll draw here. They observed it with fur. I'll draw fur. That's fur. And they noticed that amber, which is like tree resin. So amber. If you were to rub the fur with the amber would attract feathers. And that's pretty much the extent of the experimentation and the observations and speculation and modeling what they came up with. They just noted it. And it's just interesting to note that in about the 1700s that electron or electric was coined. And it's basically the name of amber in Greek. So electron is amber in Greek. And also, amber in Greek was named after the cloud nymph, a god in mythology, a goddess or whatever, a cloud nymph, and her name was Electra. I think it was K, actually. So that's sort of a little bit of background of the naming of it. And they noted Electra was a lightning nymph, so they also noted sparks. I don't remember exactly reading that, but it's likely they did. So if you were to charge that body and you were in nighttime and you were to bring them close together again, you might see an arc of energy, so electric arc. But they really didn't get much further until the, let's say, the 1700s, during the Age of Enlightenment. And they started playing around. And that time when their professional experiment kits, they were basically used glass rod. So glass and silk. They used silk rags, silk cloth. And they didn't really go by positive and negative charge. That came about, that was popularized and more or less explained in great detail by Benjamin Franklin, who's more or less, you can consider him the father of electricity or electronics, or the study of electricity, as much as he was the father of the country. But in this case, what is they called this would be called, this right here would be called resonance. And this would be called vitreous, I think. Vitreous. And they both mean resin-like, and this means glass-like. So we know now, and I'll get more how we do know that pretty soon, but when we do have these charges developed, in this case, if we were to rub the silk, we would be rubbing off negative electrons from the glass. So two different materials are required, and one of the material has to rather want electrons, and the other material tends to want to give up electrons. So in this case, vitreous material tends to give up electrons to the silk rag, and the silk rag will become negatively charged. And then in amber's case, or resin, it actually gains electrons, and electrons leave here and leaving a net positive charge on this guy, on the fur. So now you have two charged bodies, and that's basically how you develop a potential difference or a charge on two different bodies with friction. Other things to point out here too. So first, let me clear this up first. So electron is a Greek for amber. And Electra is a lightning